At part 1, we studied how the sound is reflected and transmitted when sound meets the flat surface of discontinuity like this. But at part 2, we will introduce the more complicated case, more sophisticated case. What if the sound, the generated sound meets the obstacle look like this? For example, like this, or like this. Depending on the size of obstacle, the wave, the degree of scattering of wave will be different. Therefore, we will talk about at chapter 4, scattering and diffraction. For example, I generate a sound. What if there is a big war? Then the sound is propagating, and then there will be some acoustic pressure fluctuation. Therefore, even if I cannot see someone over here, this guy can hear my voice. That we call the diffraction. And how this diffraction is related with the scattering. And also, if you see this case, when I shout over here, then it meets the flat surface of this continuity, and there will be some transmission. That means this surface would vibrate. Therefore, it is related. Therefore, the radiation, scattering, and diffraction are all related together. So we will attempt to explain all these three concepts with a unified way. Okay, that will be handled in chapter 4, and in chapter 5 we will talk about acoustic wave in small or large space. When I generate a sound, for instance, in this room, the sound is generated and propagated in many directions. And depending on the wavelengths, this space could be regarded as a large space. Suppose I am shouting in a big concert hall. Then comparing with the size of a concert hall, the wavelengths I generate, for example, this kind of sound, this is 1 kilohertz approximately. The wavelength is about 0.34 meter. Therefore, this wave will look at the concert hall, it's a very big size. But suppose I am blowing small bottle, like a beer bottle, then the sound is generated. Then the acoustic wave that is generated by the presence of beer bottle would be the wavelengths that is generated by the beer bottle would be much larger than beer bottle. So that case, we can say the acoustic that is a small space in terms of wavelengths. So we will talk about acoustically large space as well as a small space. So in this chapter, you can understand the Helmholtz resonator, like how this kind of bottle will generate a sound, and the various musical instruments. And I blow this, and the musical instrument generates a sound. This is the case when we have a small acoustic space over here, but a relatively large acoustic space. Or we will talk about how to design the concert hall or lecture hall using the concept we just talked about. So in this case, the space is much larger than compared with the wavelengths of interest. And we will also study famous Sabins. theory, reverberation time, or period, how this measure is related with the quality of the concert hall. Thank you.